Swayam Prabha. Digital India. Educated India.
So, let us continue with our different types of attacks in the network. So, we will now talk about denial of service attack. So, obviously, it is an very malicious attempt, and what it does? It makes server or some resource or the service unavailable to users. And remember, we already told that the three security aspects are confidentiality, integrity and availability. So, that is where availability is coming in, and it is usually performed by temporarily interrupting or suspending the services of the host. So, temporarily interrupting, that means when it starts happening, you may not feel that it is a kind of attack that will affect you or something like that, but over the time it takes over, okay? And then ultimately it may permanently disrupt the activities, that means deny the services that you require, and firstly maybe say one service, then next time some other service, then next some other service, like that. It may progress like this. Attacks may be distributed and involve forging of sender addresses, that means it will take IP address spoofing attack as its you can say weapon, so that the location of the attack sources cannot be identified. So, that means if the attack is from several different IP addresses and those IP addresses are also not the correct one or the righteous one because they have been spoofed. So, how do you identify which is the actual attacker? That is what is said over here. That means, that is how DOS eventually takes the, you can say, lethal form. So, in this way IP address spoofing may happen. Okay. So, you have your real attacker whose IP is something. So, it assumes the IP of this 3.3.3. So, that is the spoofed IP address. So, after all the destination is 2.2.2 something. So, it goes over there through different routers, and if it is wireless access points, internet and other servers. Now, this destination which is 2.2.2.2, it finds that the source from which the packet is coming is 3.3.3, right. Okay. So, what it does? It will send its acknowledgement or reply or whatever to that, okay? Because now I am the destination, I am getting some message from you. So, I will send the acknowledgement to you, but actually you have not sent me the message. Somebody else has taken up your address and sent me that, but I do not know that somebody's address. So, my answer is never going back to 1.1.1. So, in this whole game, many of the IPs are becoming the target, whether direct victim or indirectly they are targeted. Now, how do you know that this denial of service attack has happened? Okay. So, obviously, unusually slow network performance, when it takes time, unavailability of a particular website, okay. And many a times we have faced such things, right. Dramatic increase in the number of spam emails, it also happens, and that too particularly to some server you may find, right. Not for all mail servers you will find this, maybe for some vulnerable mail servers it happens. Disconnection of a internet connection, obviously this may happen after this unavailability or slow performance. Long term denial of access to the web or any internet services, that means firstly it was like on and off, that means not so frequent, but later on it will turn to be frequently. So, ultimately it will be long term and then inability to access any website, any in the sense that means maybe in that domain, whatever region you are in, or the whatever say types of website that you wish to visit, any of these will be in the list. So, what will be the problems faced? Obviously, in and around the attack site, that is why related sites may be affected, okay. Maybe the entire geographical region, crash services and or flood the services. In fact, these two you can say they are some sort of as if dependent on each other, dependent in the sense that means related, not dependent, sorry, related to each other. If the service is flooded, then also it exhausts resources. So, ultimately when the service is again asked for, you cannot give resource, the service crashes. So, this is only denial of service. So, the different attack techniques, that means how this DOS attack may happen. Firstly, spoofing. So, the goal is to flood the victim with overwhelming amounts of traffic. Packets with spoofed addresses are suitable for such attacks. So, as you have seen over there, that means if this is the scenario and if this attacker it starts sending large number of packets. So, obviously, ultimately this IP 2.2.2 it will be over flooded, right, and hence it may exhaust its resources also, because each and every time the message is coming and even before processing it the next one is coming. So, the buffer may be overflowed, many things may happen. Okay. This is what is meant. So, packets with spoofed addresses are suitable for such attacks, because you can't also identify that always the packet is coming from the same address. So, that becomes some other sort of problem. DOS attacks that use spoofing typically randomly choose addresses from the entire IP address space. Okay. So, this is also very important. That means, how do the attackers know that this will be valid IP address, this will not be chosen or something like that. But all of you know that since our networks are very, very large nowadays, we have so many number of not only addresses, but unused addresses also. Okay. And if you are an attacker, obviously you are intelligent. So, you can easily find it out which of the network addresses are not being in use temporarily or say for the long time, like that you can find it out. However, nowadays more sophisticated spoofing mechanisms are present that help in avoiding unroutable addresses or unused portions in the IP address space. So, that means though it is called randomly pickup, but actually it may not be that random, because there are mechanisms which will tell you the differences between the addresses. Okay. So, intelligently pick up the addresses and hence the victims cannot also distinguish, because so many different IP addresses are there, whom to block. So, services vulnerable to the IP address spoofing are remote procedure calls, RPCs, any service that uses IP address authentication, obviously very obvious, okay. The X window system, the different remote login suites, remote services suite, all these are affected. So, what can you take as a defense against such? So, one may be the packet filtering. That means, you can check the packets for the source, for the destination, and sometimes for the contents also. Contents in the sense, that means the divisions of the contents, that whether it contains tag, whether it contains this and that part, then that part, and so on and so forth, that can also be checked. So, the gateway to a network usually performs ingress filtering. That means, packet coming into the network, what does it check? Which ingress filtering means the blocking of packets from outside the network with a source address indicating an in network address. Now, since the packet is coming into your network, so obviously, the source address will be somewhat different from this network's address. Suppose it is coming for network A and the source address also belongs to network A, it cannot happen at the gateway, because gateway is getting packets from outside this network, I mean for incoming packets. So, this is ingress filtering. So, there the why this will happen? Because the attacker may choose some IP address which actually belongs to this destination address network. So, ingress filtering can happen, and similarly the other is egress filtering. The gateway would also perform egress filtering on the outgoing packets. So, it is the blocking of packets from inside the network with a source address that is not in the in network address. So, that means the attacker may choose some address which belongs to the outside network address, but actually it is going from this network. So, obviously, this cannot be a valid packet going from originating from this network. So, egress filtering may be performed and thus these packets may be filtered. And TCP also uses sequence numbers. Those of you who have learned the TCP protocol knows that. Okay. So, there are sequence numbers in the packet, and the sequence numbers are determined only after the negotiation phase is complete. So, whether it starts with 0, 1 or some random number, nobody knows, only the communicating parties know. So, TCP uses sequence numbers negotiated with the remote machine to ensure that arriving packets are part of an established connection. So, you know that if the first number is 1, then the second you are expecting is 2, or depending upon if there is some algorithm that it will be 1, 3, 5, 7, whatever be the case, but the negotiation has already been done, established. So, the expectation is also that, but only the communicating parties know this, the others do not. Okay. So, if anybody spies on the communication channel, takes up a packet and then again tries the replay attack, remember, it may fail because the sequence numbers will not be the desirable one. TCP uses sequence numbers negotiated with the remote machine to ensure that arriving packets are part of an established connection. Since the attacker normally can't see any reply packets, the sequence number has to be guessed in order to hijack the connection. Okay. The attacker normally can't see any reply packets because of the fact that the reply packets may be simply SEK packets, very small. Okay. So, the attacker may not put any special interest on those packets, because everybody thinks that if the packet is heavy, then it will contain many information and it will actually affect the victim, right, the target. Hence, those may be, these acknowledgement packets may be overlooked, right, and therefore, the reply packets, since they are not seen, so the sequence numbers have to be guessed if you take up something. Okay. You want to replay it, if you replay it as it is, then also it is not matched, right, because in the meantime some other more sequence packet may go on, hence the receiving party will already detect it. And generally the sequence numbers are in the increasing order, whatever be the sequence. Another is ICMP flood. ICMP messages have you seen? You have seen in the Wireshark, is not it? So, you know that ICMP is used as internet control message protocol part of it, and the attack technique may be the ICMP flood. So, it is used by network devices to send, say for example, error messages among many. I am just, this is an example, okay, indicating for example, that a requested service is not available or that a host or router could not be reached. And ICMP can also be used for relaying the query messages. So, at least two uses of the ICMP can be utilized in some different ways. Okay. Firstly, that say the requested service is not available, unavailable, or a host is unreachable. So, obviously, you can use it to say and say and say the same thing or the some other thing over and over to different entities in the network. So, ICMP flood, that means the floods the network with this message, or since it can also relay the query message. So, the same thing can be replicated, relayed to all the sites over the network. I mean all the sites in the sense of that, that means most of the sites. So, this is ICMP flood. Another is SMRF. Before that, I will tell you about this DDoS. We have already talked about that, but I have not mentioned specifically the terminology. Distributed denial of service, that means when these IP spoofed packets come from different IP addresses, it is called distributed DOS, because the attacker is not only using one single address, one single spoofed address, because if the attacker uses one single spoofed address, it is very easy to indicate and determine and then block. Okay. Hence, the attacker may use different IP addresses, which is very, very difficult to determine, and hence this is distributed denial of service. So, the SMRF attack is a DDoS attack in which large numbers of ICMP packets with the intended victim's spoofed source IP are broadcast to a computer network using an IP broadcast address. Those who have studied network, I think they know that there is a broadcast address in the network. So, you see how, I mean, you have to give the technology the ease of use. So, but you have to use it responsibly. Okay. You may not use it for spreading such attacks, right. So, that is the difference here, nothing else. So, what it does? The ICMP packets have the victim's spoofed source address and they are broadcast. Therefore, you understand that at single point many such other IP addresses, target IP addresses are flooded with flooded with message from one single spoofed address. So, you understand what will happen then? Everybody will try to acknowledge, try to reply. Most devices on a network will send a reply to the source IP address. If the number of machines in the network that receive and respond to these packets is very large, the victim will be flooded with traffic, obviously. This is going to happen. So, this can slow down the victim to the point where it becomes impossible to work on, because the victim is always in the mode of replying, or replying what? That means, since it is getting some SEK, so it may think that I have to provide something to it, even say hello. Okay. Either this, or it is simply overwhelmed by the number of messages, because it does not have so many buffers, the time to process them. That means, why they are coming from them, why they are coming from all such addresses, to identify the addresses and block them. All the resources have already been exhausted. So, the victim will ultimately slow down, and later on it may not work at all. Another is ping flood. Ping you know, I think everybody knows what is ping. So, ping flood is based on sending the victim an overwhelming number of ping packets. That means, from Unix like hosts which has the ping commands. Can you write some command which is like ping command? Create some, what does ping do? You simply replicate that activity, you can maybe, okay. It is simply form of listener, finds out whether you are okay or not, sends some maybe very simple hello packet and gets a reply back. So, if you do this in large numbers, suppose you are supposed to send say one ping packet say per second, but you are doing say 1000 numbers per second. So, obviously, it is a flood. And the same thing, how will the target answer reply back so quickly? Because the target is not used to processing the replying in such quick succession. This attack technique is based on the SYN, SYN, synchronize. What is that? It utilizes the three-way handshake TCP mechanism. What does TCP do? The TCP client will request a connection by sending a synchronized message to the server. What does that mean? That means, I want to talk with you kind of message, okay? And the server acknowledges this request by sending the SYN SEK. Obviously, that okay, I will talk with you if it is fine. Maybe the client has sent all its other credentials and the server finds that everything is okay. So, it will say yes, yes in the form of acknowledgement message. Now, the client has to respond with an acknowledgement, because then only the connection will be established. This is the total protocol. So, what happens here? Let us see. A SYN flood occurs when a host sends a flood of these packets, often with a forged sender address. So, there is the attacker which takes the identity of different spoofed IP addresses, okay, and tells the server that I want to establish a connection. So, connection 1 is telling I want to establish connection 1, spoofed address 2 is telling I want to establish connection number, spoofed address 3 is also telling the server I want to establish connection, everybody is telling, the server will be very happy, is not it. So, each of these packets will be handled like a connection request, because the server may not have any way of identifying that they are forged addresses, okay? Because they may be valid addresses. So, how do you know that they are, those addresses are actually not giving you the request? Okay, that is the problem, because the attacker is very intelligent, it is picking up valid addresses. So, what the server will do? The server will obviously send this second message TCP seen SEK, okay, it sends back, but now it is for the client part to send the SEK message back such that the connection is established and data transmission starts. But actually that forged IP address has never requested the server. Okay. So, even if it gets some seen SEK, it understands that there may be some problem. So, it does not send any SEK back. So, all these connections are half open dangling. Actually what it means? That means the server has exhausted its resources in keeping these half open connections, because the server also does not know what to do next, how long to keep these half open connections open. Okay. Maybe it has to sever these connections, but maybe after some times, and after that sometimes if the attacker is still active, it will still go on sending, right. So, this may continue and hence flooding may occur. So, and the next steps you know, that means if flooding occurs, so the server is exhausted, so resources get depleted and so on and so forth, who will be affected ultimately. So, the response never comes and the malicious client thus binds the resources on the server and may eventually exceed the resources available on the server, very simple. Another is for the peer to peer, the attacker instructs the clients of the peer to peer file sharing hubs to disconnect from their network and instead connect to a victim. Actually, it does not say that disconnect from the network, it simply says that maybe this is not working. So, change your peer to this. Okay. So, obviously, if I am a client, I may not disbelieve, I may simply change the connection, because I may think that it is telling the right thing. So, this may be the right thing to do. So, I will change my connection to some victim, a victim in the sense, why victim? Because now I will flood him with message that give me that, give me those things, why are you not giving? And not only myself, there are several such. Okay. So, this is what can be done in a peer to peer. Another is permanent DOS attack, PDOS. Permanent DOS exploits the security flaws which allow remote administration on the management interfaces of the hardware, such as routers, printers or other networking hardware. What does that mean? That means many a times you see we tend to move on with whatever default password or whatever default say addresses are given to us by the vendors, is not it, when we buy all these hardware. I mean many a times we do that. Okay. So, the attacker uses these vulnerabilities to replace the device's firmware with a modified, corrupt or defective firmware image. Okay. So, that means what happens therefore? Since these vulnerabilities are already known, so there is no problem if the attacker tries. I may have replaced, okay. I may have modified, I am not using the default things. So, in that case I may not be the victim, but some other parties may be the victim who has not changed, who is using the same things. Okay. So, that is permanent DOS attack, because your many important things will be replaced by a modified, possibly corrupt or defective firmware image. So, you may not be able to do anything, and thus it is a permanent attack.